Hello, welcome to m253 Calculus 3 here at Cañada College. In this video, we will take a peek at section 2.1. So we're in chapter 2, we're going to dive into section 2.1 and take a look at what's in there. We're going to study vectors on a plane. We're going to start off by looking at some vector definitions and some notation, some basic ideas. And the basic idea is that a vector has a magnitude and a direction. So if you have a couple of vectors with the same magnitude and the same direction, then those vectors are going to be equal to each other. We also have some terminology that we're going to use. I usually call it the head and the tail, but we can call it the terminal point and the initial point. So the initial point is a tail, that's the beginning of the vector, and it goes to the terminal point, or the head, which is the end of the vector. Next, we're going to take a look at some vector operations. We're going to focus a little bit on scalar multiplication, and that is to scale a vector, essentially multiplying a vector by a number, which we'll end up calling scalars. So twice of a vector v will be twice as long, half would be half as long, and a negative of a vector v would actually have it going the opposite way. We're also going to take a look at vector addition. A good way to visualize vector addition is that if you want to add v plus w, we can put the tail of w to the head of v, and then starting from the tail of v to the head of w is going to be our new vector. We can visualize this in a couple of different ways. This is sometimes known as the parallelogram law. Subtraction can also be seen as an addition of a vector and then another vector that's scaled by a -1. So we can visualize that any way we want, but between vector addition and vector subtraction, we can use the idea of a parallelogram and take a look at their diagonals. After some vector operations, we're going to establish more information about vectors, namely components. We're going to take a look at vectors and identify them by components so that we can do some basic algebraic operations on them. We can visualize a vector in home base, in standard position we call it, where the initial point or the tail is sitting at the origin and the terminal point is going to be whatever point it is, let's say xy, and then we can call that vector x comma y in vector components. We use these alligator brackets or greater than, less than bracket signs to symbolize our parentheses. In this class, that's what we'll do. And we can take a look at the scalar multiplication and the vector additions that we just saw in terms of the vectors. Now that we have components, we can perform the symbolic computations. After some components, we're going to take a look at another important operation for vector, and that is the magnitude. The magnitude is essentially the length of the vector. So if we take a look at the x going in the x direction, the y going in the y direction, the magnitude of that vector that we're looking at is essentially the distance, or you can use Pythagorean's theorem or whatever else might be useful. But essentially the magnitude of xy is going to be the square root of x squared plus y squared. We're also going to relate the magnitudes with the angle associated with a vector from the positive x-axis. And we'll see that come into more important fruition a little bit later on. And then we're going to take a look at unit vectors. Sometimes we're going to want a vector of a specific length, and we can't just multiply a vector by 5 and expect it to have length 5, because if the length of the original vector was 2 and you scale it by 5, then it's going to have length 10. So one way to do this is to what we call normalize the vector, and we essentially make it into a unit vector. And the way to make it into a unit vector is that we divide by its magnitude. And in doing so, we can scale the vector to whatever we want. And speaking of unit vectors, there are two important unit vectors in 2 dimensions. It's known as the I and J vectors, and the I and J vectors are unit vectors pointing in the X direction for the I and the Y direction for the J. They end up being important vectors for us. They are called the standard basis vectors because now we can rewrite a generic vector x, y into x in the I direction and y in the J direction. Finally, in this particular section, we're going to take a look at some applications of vectors, vector addition really. Some of the applications that we can focus on are tugboats pulling a ship, or the wind speed, air speed, ground speed of a plane flying about, and a few other applications that we're going to run into. Okay, so that is our overview of section 2.1. Good luck.